Hi, I'm Andy Parkin, Managing Director of the multi-award-winning Speed Screed. I'm here to answer the question, why has my screed cracked? Now, it's quite a difficult question to answer, but I'm going to give you a good overview and hopefully may give you some ideas as to why this may have happened. As with any screed issues, we need to find out other details relating to it. So it's a case that we're not just repairing the symptom, we're actually understanding the cause. Because what we don't want to do is we don't want to then suffer a repeat of the original cracking. So we've got to look at the possibilities why screed cracks. It's quite a common thing to see. So initially, it's not one of those things that seeing a cracking screed means that the integrity of the screed is affected. It needs to be removed. It's defective. It's quite a natural thing to do. The product shrinks. So there's going to be, an element of shrinkage cracking in there. So it's about the control of the shrinkage cracking, whereabouts it cracks. Is it, is it okay to crack there? Isn't it okay to crack there? So if we examine some of the reasons why you may experience cracking, and I'd also put in there a sort of general breaking down of the screed as well. So, you may start with a crack, but that might be a symptom of something else that's underlying, and the screed may break down further. You may have a crack that's then trafficked, loaded, that then starts to break down. So that's a different issue in itself. So there's lots of considerations to make, but just to run through an overview of why it may crack, you're looking at if the wrong materials are used. So when we're saying wrong materials, we're meaning that it's the wrong type of screed. So it's not suitable for the application. It's been specified incorrectly. It's been put into a situation where it needed to be perhaps deeper for that particular product. So it's the wrong product that's gone in. So making sure that the correct product, the product that's being used, is suitable for the application. The screed will only be as good as the substrate that it's on. So if the substrate is not sound, wasn't dry, if it was contaminated, and it was not stable, if you've got insulation on top of a structural substrate, have you got rocking? Have you got some gapping that you start to compact screed into? There could be weak points there that then lead to cracking. So the preparation is always key when looking at any screed, and the problems generally will then surface in the screed. Has there been too much water, too little water? Too much water means that you're going to get excessive shrinkage and more cracking. If there's too little water, then that means that the cement can't hydrate or won't hydrate all the cement particles, so you're going to end up with a weaker screed. So that may be an issue. Staying on the subject of water, has the screed been cured? So when we're saying cured, it means retaining for 7 days the water within the screed. So it's not dried out too quickly, there's not been wind tunnels in the building. Certainly kind of May through to October time is key times when screed should always be cured, as per the British standard. So the screed may dry out, you may end up with dusty surfaces. In extreme cases, you may experience some cracking because of weakness. It could be poor mixing practice on site. Now that could be a multitude of things. It could be the way the screed has been mixed. Has it been mixed with just a shovel on a board? Has it been mixed in a free-fall mixer? So it's not mixing properly. You're getting balling. Freefall mixer's not suitable for a semi-dry mix. Is it that there's not enough cement in the mix, as the cement ratio is not being adhered to? So that could be a reason why the screed starts to break down. Is it the wrong grade and quality of the sand? Is that suitable? Does it meet the British standard? Is it started to break down because it is the wrong grade? Is it too fine? It may look a nice smooth surface finish, but if there's no sand at the top end of the grading, then it's going to lack some strength. So maybe it's the wrong grading of sand. Compaction is a major consideration for sand and cement. So it needs to be compact in layers. So layers of 50 mil. So if you've got 100 mil screed, that's 2 layers. If you've got 150 mil screed, that's 3 layers you need to be compacting in. If you don't compact in those layers, then you're going to end up with a nice crusty surface, but then nothing substantial underneath. It's gonna crumble, and you may see a breakdown of the screed and also some cracking. Has the screed been trafficked too early? This is something that tends to happen on sites, busy sites. Contractors can't wait before the next trades are getting in, so it's early trafficking. So that's foot traffic, point loading, heavy loads are subjected to the screed. So that can be, it can be impact as well, so that you can see cracking related. So all these things, the screed from the moment it's laid to the time when the floor coverings go on, British standard states that the screed should be protected at all times. Has there been any stress relief joints? So as we mentioned, this is probably the single biggest factor for cracking in screed. So I would say probably 90% is going to be down to shrinkage cracking. So to try and manage shrinkage cracking, I don't think you'd ever say that you're going to alleviate any shrinkage cracking, but to manage it, you would be looking at cutting it into bays. You'd look to put polypropylene fibres in there as well, and both those two things will minimise shrinkage cracking. So it's making sure you're putting the stress relief joints in the correct places to take into account the size of the bay, the shape of the room, and any restraints that are in the floor. So often, if you're seeing shrinkage cracking, it's coming off corners, it's coming off restraints like columns, it's going across doorways. They're classic shrinkage cracks. Movement joints. Has the screed got movement joints in? And when we say movement joints, that's to allow for movement within the building. So within the substrate and in the structural element, you may well have movement joints. The screed should mirror those movement joints. If they don't, then you may find, if the building is moving, and from that 1 mil, you may end up with a crack actually in your screed. So the other thing that you need to look for, did it have edging strip? So has it got somewhere for it to move? So edging strip, that can also be insulation as well around the edges. So as the screed moves, if it pushes up against something that it can't move, then that's a restraint, and you can see restraint cracking. So it's important to have the edging strip there just to allow and facilitate that little bit of movement. Generally, these type of screeds are all non-wearing screeds. There are a handful of products that are wearing screeds, but the majority aren't. If it's trafficked and not protected, then again you're going to see a kind of wearing down of the screed. You may end up seeing some cracking in extreme cases as well. So it does need to be covered until the floor coverings go on to ensure that you get the maximum performance from the screed. Thermal cracking is something that we see as well. So the screed only will move once by itself, and so that's during the shrinkage process. After the shrinkage process is completed, the product is classified as inert, so it won't move. The only time it will move again is by external forces. One of those is heat. So if it's a heated screed and you've got thermal movement, it may potentially, if the joints aren't sufficient, it may build up that stress and then look to lose the stress, and it'll look for the weakest point and crack along the weakest point. With thermal cracking as well, you may get differential thermal cracking. Now that's where you've got two areas that are heated at different temperatures, and you've got that differential, so they're moving differently and they crack, effectively down the middle. It might be, in a doorway between two rooms. One might be, say, a corridor that's kept at a relatively low temperature. The rooms are heated to, a higher one, and you can get cracking there. So if there's no joint, there may be the possibility of thermal cracking. As we mentioned, the screed won't move again by itself, so it could be that the building moves. So where there's movement joints, that might be a case where the building's moving. It could be heave. So there's something going on underneath. The substrate is pushing up and it cracks. So forces placed on the screed afterwards may cause cracking. So these are just some of the causes. It really needs investigating. It really needs looking where the cracks are running from and to. It needs to know the history. What is the substrate? What's gone on to the substrate? It needs a lot of investigation. On the surface, shrinkage cracking often appears quite obvious, and there are those telltale signs. And so I think it's probably good now just to really run through some of the repair procedures. It's very rare that a screed needs to be replaced, so the repairs are generally fairly easy to do, and I think we just probably classify them in probably three areas, and I'll just run through them just to give you an idea. So for general shrinkage cracking, and we wouldn't really look at repairing any cracks generally that are less than 0.5 millimetre or less than a credit card width. So the British standard states hairline cracks are generally not required to be repaired. Now, if you've got isolation of screed, so you've got a piece of screed that's rocking and isolated, then that might be something that needs to be addressed. But generally, when you're repairing cracks, you need to be able to pour a low viscosity resin in. And if you've just got a hairline crack, you can't actually do that. So then what you'd have to do to get the resin in is you'd have to open that crack up to a 2-3 millimetre extent. So you can see that you're starting off with a relatively stable screed that just has a hairline crack in, and then you're going to have to drive a sort of 2 or 3 mil crack into the screed using a grinder. So you can see that in certain instances, the answer is to leave well alone. If you are repairing the crack, you pour the low viscosity resin, a 2-part resin, into the crack. If it's quite a wide crack, you may bulk fill before you do this with a kiln dried sand. So you'd bulk it in and then pour the resin over the top. You'd wait probably 15 minutes to allow it to settle, and then you'd pour again and top off. You may do that again as well, just in case it runs. Sometimes you may have a little bit of a gap under the screed, and it starts to fill that up. So sometimes it can run a little bit further than you anticipate. For a generally weak screed, so if it's not sound and it's starting to crumble and you think it's because of lack of strength and other things, then a penetrating resin might be the answer. So what that is the resin actually sinks into the screed. So it's got to be open textured enough to allow that to happen. So sometimes the surface needs to be mechanically abraded to allow the resin to sink in. But that sinks in and then it hardens and strengthens the screed. Now that's quite an expensive process, and it is actually cheaper generally to remove the screed and to start again. So you'd probably look at that if downtime wasn't an answer or wasn't possible. Sometimes removing the screed is as cost effective, as we say, against the penetrating resin. But if it's kind of spot areas, then it's probably a good idea to remove the screed in that particular area. So it might be a classic area that's damaged is the entrance to a building. So you've got all foot traffic, you've got wheelbarrows, you've got other loading on that particular area, and that can often get damaged. So rather than trying to patch it up, repair mortars and other products, it's often better just to cut that area out and to relay. If you're worried about getting the floor coverings on and things like that, you may go with a fast drying screed, so you've not going to be delayed any further. But that's an overview of cracking and repairs. As I say, probably 80–90% of all cracks relate to shrinkage cracking and in themselves do not affect the integrity of the screed. And it's something which is relatively common with screeds and concretes. You try to minimise the shrinkage cracking with joints, with the fibres, but there are no guarantees that it won't crack because of that. So I hope that's been helpful. If you need any further information, please get in touch and we'd be only too happy to help. Thank you.